Hello everyone, welcome to this video lesson. I am Chidumen Namdi. In this video lesson, we are going to learn about the Angular signal inputs. Now let's dive in straight in. The best way to learn about the Angular signal inputs is to compare them against the traditional at input decorator. Now see here, we have a parent component that renders the counter component, which is this. Now in this our parent component, we are passing the counter value to the counter component via its value input property and then passing the counter there. So this counter component will receive this counter value via its value class field. Now going to the counter component, we see that we decorated this value class field with the at input decorator. So with this, Angular marks this as a DOM property in which a value will be passed to this counter component from a parent component. You can also see it from the definition of the at input from the Angular docs. It says decorator that marks a class field as an input property and supplies configuration metadata. The input property is bound to a DOM property in the template. During change detection, Angular automatically updates the data property with the DOM properties value. Now, we have a ng on changes. Now, this ng on changes is run whenever the value of this input changes. So, it passes the changes metadata, then we'll grab the change and then log the change here. So, we just added this lifecycle hook so that we can always log to our DOM browser whenever the value of this input property changes. Now let's run our component. We see it here. The counter is being displayed here and the increment button from the parent. So whenever we click on this increment button, we'll fire this on increment handler and it comes here and executes this on increment method. Then inside it, we see that it increments the counter value by 1. So originally we have 10 here. So when we click on this button, it increments this counter value from 10 to 11. Then once this is done, an Angular change detection will be run on this component and its template will be updated. So in doing so, it will update the counter component. So we go to the counter component. It will re-render this and update its component. Then after that, it will then run this ng on changes. Also, the property 11 will be passed to this counter via this value, and this counter component will grab it from this class field value and then display it in the template so that whenever we click on this increment, you see the result and then the login in the DOM browser. Now let's convert this to use signal inputs instead of the traditional at input decorator. Now, this is what we are going to do. We will first remove this, then remove this 0, and here we will call the input. So the input is a method in the Angular signal that converts a class field into a signal input. So we will pass the value 0 as the default value. Now we see that in our template, we have these squiggly yellow lines telling us that this should be invoked. So looking back at Angular signals, we'll see that whenever we use a signal and to extract the value, we need to invoke it as a function because it becomes a getter function. So now this converts this field to an input and also returns a signal. So you can see it initializes an input with an initial value if no explicit value specified. Angular will use undefined. So you see this makes this class field to be a signal and also making it an input at the same time so that it can receive value from a parent component and then we can now display it in our template. Now whenever the value of this class field is changed from the parent component, then it will invalidate this value here. And then when this component is rendered, we will see the current value here. Now, this is a function, so we need to invoke it. as a function by calling it with a parenthesis. Now let's save it. Okay, then we click on the increment. You see that it's running as usual. So you see we have converted this component from using the at input decorator to use the newest feature in town, which is the signal input, and it works as expected. So you see now there's also a feature in Angular signals, which is the effect API. This is used to run a side operation whenever one or more signal value is changed. Now we can remove this ng on changes and replace it with the effect API, so that the effect API will be dependent on this signal, and then whenever this value changes, the effect function in the effect API will change. Now you can take a look on my video on the Angular signals and also Angular effect. I have a concise and a complete guide on the two topics so that you can learn more on the Angular signals and Angular effect API. Now let's change this to use the effect API. Now the effect API can only be used in the injection context in Angular, which is in the constructor, inside a component, directive, or a service. So we'll first create our constructor and then call the effect API, which is also imported from the Angular core module. You see it. Then we pass our effect function there. Now inside this effect function is where we will call this. Then we'll remove this ng on changes. Now see, in the effect we have no need for this change at all, so we need to remove it. And inside here we will call the value because it's a signal. You can also see it here. You see an input signal which is of a number value. So to grab the value, we need to invoke it as a function because this is a getter function. Now we will save this. Now doing this effect has replaced the work of the ng on changes that was initially defined here. Now we are using the effect, and by calling the value here, now this effect is not dependent on this value signal, such that whenever the value of this signal is changed, then this effect function will be invoked, and in doing so we'll have a log here. So you see now it now has the same operation as the ng on changes. Now looking at our browser, you see that we have the log here, yeah, which shows us that this works perfectly. Now when we increment our counter, we have a log on each increment, now which shows us that this effect works perfectly and the function is called whenever the value signal changes. So we have seen how we converted a traditional at input decorator to use the newest signal inputs. So now you can see that using the signal input is much cleaner than using the at input decorator, because the at input is much more complex to use. Also, notice that we did not have to change the signal input component when we converted our counter component to use the Angular signal input instead of the at input decorator. So nothing was changed here and it still worked. Now, coming to the counter component, you might be asking what happens to the effect here when this component is destroyed. Does it leave the effect hanging? No, it does not leave it. Whenever the component is destroyed, the effect in the component also, or all the effects defined in the component also, are destroyed. None is left behind. Also, we can manually destroy an effect. Now, this is how we do it. To manually destroy it, we can get the effect ref returned from this effect API and store it in a class field like this. Then give it a data type naming, which is the effect ref. Then we can now access the effect ref and assign it to it. So we will now come on ng destroy, ng on destroy, and then we'll call the effect ref dot destroy. So this method destroys the effect here whenever the component is being destroyed. So you see the engine destroyed is a life cycle hook that is called before a component is destroyed. So here we are just making sure that this effect is destroyed, but this is not necessary because by default all effects are destroyed whenever the component is being destroyed also. Now let's remove this. Now we can set input options in our signal input just as the same we can do with the traditional at input decorator. Now we can make this input to be required. We can also set an alias on it and also set transform option to it. Now let's look at how to set required. Simple. To set a required option here, we come here and call the required like this, then passing the type. Now with this class field becomes required, so it must be passed from the parent component. Then as it must be passed from the parent component, it does not require an initial value because it is a must. So we have to remove it and then save it. It still works. Now if we come here and remove the input, then there will be a compilation error because we set to this value input to be required. So we must pass an input to this component. So if you pass an input to it, you see all the error goes away and our app successfully renders. Now let's look at how we can set an alias to our input. To set an alias to take another name, we need to call this input with another second option which takes an object, and then inside the object we can define a property alias and then set the name we want to receive this value as. So you can see it here, the alias optional public name for the input. By default the class field name is used, so let's call it that we want to make it to be counter. So with this counter here, we will not pass input to this counter component by specifying this value done property. We are now going to use the counter done property. So using the value done property will result in a compilation error, which we have seen here. So and we see here, we will see the squiggly line telling us that it can't bind to value since it isn't a known property of counter. So what we have to do is to come here, change this value to counter, and everything works. So we can also set the transform option. The transform is a function called to work on the input coming here before it's being set as the value of this input field. So to do that, we have a transform option also, and then it's a function that takes the input and then it must return a value. So to check, let's log this input to see what's coming in, and then let's just return a double of it. Then we'll now say input times 2. Okay, no, we don't have to use the input because we're already using it here. So let's remove it. Let's say value, and here value, here value. Okay, step of unknown. So what's coming in is a number. So we do it like this and we'll save. So you see it works. what is coming in is being logged here 10, and then we'll multiply it by 2. So 10 being passed in here and then coming in, this transform option is called. That's why we have this log in our browser, and then returned the transformed value, which we are multiplying it by the original value coming in by 2. So the original value coming in is 10, multiplying it by 2 becomes 20. So that's why we have 20 here. So whatever that is coming into this counter component is transformed to a double of it by this our transform function. So if you increment it, if we press this will be 11. Then we will now see the double of it here. So you see 22. If you increment, see 24, and so on. So that's it for signal inputs. I hope we understood this video lesson and also learned how to convert a component from using the input decorator to use the newest Angular signal input, and then learned how to make the input to be required, how to set the alias, and then how to set the transform option. Then also we learned how to use the effect in the place of ng on changes to log to the DOM browser whenever the input field, the signal input field is changed. I hope you love this video. Please like and share, and also subscribe to my channel for more content like this. Thank you and see you next time.